talking about the difference between a relation and a function. A relation is just any kind of correspondence between ordered pairs. There's an x and a y. In a function, it's that special case where your x's don't repeat. And we talked about how the x was our domain and the y was our range. So we ended with deciding if things were functions or not, but we've just been looking at tables of values and sets of ordered pairs. So let's say I give you an equation, y equals 2x minus 5. Without graphing, do you have any ideas on how we could decide if this is a function? Okay, you could look at the exponents and try to decide if things repeat or not. Let's just make a table of values and kind of talk through it and see if we can decide. We know it's a function, or it's not a function, if one x value gives you two different y values, right? So if I were just plugging in some numbers, give me your favorite number. 0. I like that number too. So if I put in 0, I get out -5. If I put in a 1, I get out if I put in a 2, we get out -1. If I put in a -1, -7. If I take any number, multiply it by 2 and subtract 5, am I going to get more than one answer? No. Every time you're going to get one and only one answer, right? So what does that mean? It's a function. Yes. Did you? Okay. Let's talk about B. If I put in a number for x, let's say 0. Then y squared equals 1. So what's y? Plus and minus 1. Get rid of the square, you add square root. When you do that, you always do plus and minus. So I got two different answers. In other words, 0, 1 is a point, and so is 0, -1. What does that tell me? Not a function. Typically, things that are going to create issues would be if your y value has a square or a fourth, things like that. You need to be very cautious about. All right, let's talk about graphs a little bit. First thing I want to do is make sure we can look at a graph and give the domain and range. Okay, so this one, it's kind of hard to tell in your handout. They're actually just points. What does domain refer to? X. So, which x values does this hit?
-2, 1, 1, 4.
It's not hitting every x, just those 4 x values, because I only have those 4 points on my graph. Okay, the range. If I am talking about my y's, what y values does this hit? -3, -2, 3, and 4. Okay. B. Can I list out every x value this one hits? No. When we're thinking about domain, that's the x. So think about traveling along the x-axis. As I go from left to right, the first x value we hit is -1. And when does my graph stop? 5. And because it's a solid curve, we are hitting everything in between. So we would write bracket -1, comma 5. Range is referring to your y's. So we're going to write interval notation. Y, think about starting at the bottom, going up. The lowest y value we hit is -4, and it stops when we get to 2. And again, we're using that interval notation because it's hitting everything in between there. So far, so good? Okay, this is solid, so we are talking about an interval. So we need our starting and stopping point. This one, it keeps going both directions. So do I have a smallest and a largest number? So how do I write that? It keeps going. Negative infinity to positive infinity. Remember, infinities always give parentheses. The range, this is going to keep going down. That one keeps going up, so I don't have a smallest or largest, so my range would be negative infinity to positive infinity. Why don't you guys see if you can do the last one? What do you think your domain is? As we keep going, this parabola is just going to keep spreading out. So there's no smallest or largest. It will eventually hit everything. Okay, your range. There is a lowest value. This starts at 0. It hits 0, so that gets a bracket. And does it ever stop going up? So 0 to infinity. Questions there? In general, if we're just looking at relations, we're going to assume our domain is everything that will give us a real answer when we plug it in. So unless I tell you otherwise, that's our assumption. So my question is, what kinds of things would give you unreal answers? What kinds of things, when you plug them into your calculator, does it say domain error? We've talked about one of them already. If you have a fraction, what do you have to worry about? No 0 on the bottom. So in fractions, the denominator cannot equal 0. The other thing we need to worry about are even radicals. So I'm talking like a square root, a fourth root, a sixth root. In those, the argument or the radicand, the thing under the radical, has to be greater than or equal to 0. You have to have a positive. For now, those are the only things we have to worry about. So when we're talking about functions, we know that means each input has only one output. Okay, the x can't get repeated. So if you're drawing a graph and x can't get repeated, if I draw something like this, then that means I can't have any other point that also has an x value of 1 or an x value of 2. In other words, if it's a function, it passes the vertical line test. That means any vertical line you draw will only hit your graph one time. If you can draw even one vertical line that would hit it more than once, then it is not a function. So I'm going to look at some graphs and decide if they're functions or not. Would this first one be a function? Yes. No matter where I draw a vertical line, it's only going to touch the graph once. So yes, that one is a function. Is this one? No, because I can draw lots of vertical lines that hit this graph more than once. What about the third one? No, you can hit it more than once. This one? It's a little misleading. It doesn't actually become vertical there. It's just slowly increasing. So would this one be a function?
Yes.
Yes. It's just a little hard to tell from that graph. Alright, so let's go back to looking at functions, or looking at equations and deciding if they're functions. We talked about how to do it just by plugging in numbers, but now we know we could also look at a graph and give our domain range. So your graphing calculator may come in handy here. You're welcome to use that. On the first one, we probably don't even need a graphing calculator, do we? What's that one look like? It's a line with a y-intercept of -5 and a slope of 2. I am not going to tell Mrs. Keller how much you guys hesitated on that, because I know you graphed a lot of lines back in Algebra 1. So does that one pass the vertical line test?
Yes.
Yes, so that is a function. What would my domain be? Negative infinity, positive infinity. What's our range? Same thing. As long as your line isn't horizontal or vertical, that will be the case for every line. Okay. B, what's this one look like? Parabola. Let's just scoot it up a little bit. So is that one a function? Yes. What's my domain? Parabola's domain will always be negative infinity, positive infinity. You could also think about that by looking at the equation. I can put in any number I want because there's no fraction, there's no even radical. So it should be everything. My range, what is this lowest point? 3. My range is bracket 3, comma, infinity. Can you graph that one on your calculator? How? You notice on your calculator they're all y equals. Can you do x equals on there? No. But we could graph it by hand, couldn't we? If I wanted to make a t-chart, it would be easiest to plug in numbers for y. So let's try some negatives and some positives. I always try to do a mix of both. If I put in -2, what do you get out for x?
2.
If I put in -1, 0, 1, you plot those. This is just an absolute value graph flipped on its side. Is that a function? What's your domain? Going from left to right, our graph starts at 0 and goes on.
So how, like, could you tell that it was going to be sideways just by looking at it?
If you think about an absolute value is normally y equals the absolute value of x. So if the order pairs are or if the x and y are reversed, that's really just going to flip it on its side. What's our range? This one's going down, that one's going up, so eventually we'll hit everything. Okay. D. You can graph y equals -x on your calculator, can't you? What's that? Just say line, y-intercept is 0, slope is -1. If you graph that, do you remember from algebra 1 and algebra 2, what does that greater than do? It shades. Okay, since it's an equal to, it's a solid line, the greater than, which way is it going to shade? Above or below my line? Above. Is that going to pass the vertical line test? No. Anytime you see an inequality, if we're talking about those graphs, if you have an inequality with both an x and a y, it will not pass the vertical line test. What's my domain? Yeah, eventually we'll hit everything. You could even just think about the line. The line will hit everything. Same thing with your range. It's going to keep going up and down forever, so you will hit any within each possible infinity. E. You could graph this on your calculator if you wanted. We will learn how to graph these by hand, but we haven't yet. If you graphed it on your calculator, your graph is going to look a little bit strange. And remember, if your calculators have a weird window, you can hit zoom number 6 to reset that if you need to. You're getting something like this. This looks like it's turning vertical, but it never actually does become a vertical line. It's just very slowly spreading out. So, is this one a function? Does it pass the vertical line test? Yes, it will. Okay, domain and range.
Wait, what is, it's spreading out which way?
So, what this is really happening, there's an asymptote here, which is a line you get closer and closer to and you never actually touch it. So even though for our purposes the graph looks like it's kind of turning into a vertical line, it's just always getting closer to that one piece. Domain. We could do it from the graph, or we could look here. What's the one thing x can't be? negative 2. So your graph, it's coming from negative infinity, stops when it gets to negative 2, it doesn't touch it, so that's a parenthesis. There's more than one piece, so you put the union. The next one picks up at negative 2. Again, it's not touching, and it goes on forever in the positive direction. Alright. The range is going to look very similar. This piece is going down forever, so it's coming from negative infinity. Where does this graph stop? Where do my y values break? At 0. Again, it doesn't touch it. Union, 0 to infinity. These are graphs that we will talk a lot more about. We will have a whole chapter over these. So right now we're just trying to get a very basic. We know that you can't put a negative 2 in the bottom because you get a 0 in the denominator. So we should be able to look at this and give a domain and range and realize that it is a function. The last one. You could graph this if you wanted to. You get something like this. Is it a function? Yes. Domain, maybe you can't tell just by looking at your graph, but we can from the equation, can't we? If you have an even radical, what do you know about the thing underneath? It has to be positive. So I know that 4x plus 1 is greater than or equal to 0. So if you want to solve for x, you get x is greater than or equal to negative 1/4. You write that as an interval, starts at negative 1/4, and goes to infinity. Your range, can you tell me what the lowest y value is? 0. It touches it, and then it's going to keep going up gradually, so 0 to infinity. Okay. Talked about a lot of different stuff so far. Are there questions for me to this? So the next piece we're going to look at, we're going to talk about function notation, and then we are going to talk about increasing and decreasing. And then that'll wrap us up for today. So function notation, you have seen before, is when you have that f of x in there. F of x represents y. So it's basically saying for a given x value, what is your y going to be equal to? If I gave you an ordered pair, f of 2 equals 13, that's saying your x is 2, your y is 13. So on the next slide, I would like for you guys to go ahead and just try these on your own. I've defined some functions up at the top, and I want you to find each of those things. See if you remember how to do that. F of negative 3 means you are replacing each of your x's with a negative 3. So the opposite, negative 3 squared is 9, plus 18 plus 4. Okay, and then what'd you get? I saw a lot of you with 31. There was a negative out in front of that x squared. And you had to square before you put that negative on. F of r, all that means is you go to your equation and change your x's to r's. So negative r squared minus 6r plus 4. The last one, g of r plus 2, just means you're going to now function g. And instead of x, you write an r plus 2. Simplify what you can, so that's 3r plus 6 plus 1, or 3r plus 7. Any questions on that part? then I want to make sure we can evaluate functions if I give you something other than just the equation. So we're going to look at all the different ways functions might be represented and make sure we can evaluate. So for each of these, we're going to find f of negative 1. The first one is like what we just did. I gave you an equation, so we're just plugging in negative 1. Negative 1 squared is 1, times 2 would be 2, minus 9, which is negative 7. If I give you ordered pairs, when I say f of negative 1, I'm meaning tell me the y value, okay, when your x is negative 1. So if I look at this is the point where my x is negative 1. What is your y? 6 is our answer. Okay, on C, what's my answer going to be? 5. When my x is negative 1, my y is 5. On D, when my x is negative 1, what's our y value? 1/2. So you have to look on the graph when your x is negative 1. Our y was approximately 1/2. Sometimes we need to write things in function notation. Just remember the f of x always replaces the y. So if it's not in function notation to begin with, first you would have to solve for y, and then you can replace the y with an f of x. So in the next slide, we're probably not going to do all of these. I'll do a couple of them. I just want to take equations and write them into function notation. The benefit of function notation is it's really easy to evaluate once it's in that notation. So for this one, if I just said function notation, what's the only thing we have to do? F of x. F of x replaces y. Since it's already y equals, it just becomes f of x equals. So when I say f of negative 5, you are changing all of your x's to a negative 5. Negative 5 squared is positive 25. 2 times negative 5 is negative 10. Minus 3. Negative 12. I also asked for f of b. What does f of b do? Just change your x to a b. There's no solving involved there. Okay, the second one is a little bit different because we do have to do a little more work. If I want to write this in function notation, you don't just have f of x in the middle of an equation. We always do f of x equals. So I would have to first solve this thing for y. How do we do that? Get the y by itself. So if I subtract my 2x, we divide by negative 3. There are different ways you could write this. So my y is f of x. You could certainly leave it like this. You could split it up. Negative 6 over negative 3 is negative 2. negative 2 over negative 3 would just be a positive 2/3 x. You could put 2/3 x minus 2. Lots of equivalent ways of writing that. So then f of negative 5 plug that in. You get negative 2 minus 10/3, which is what? And again, the f of b, all you do is change the variable to a b. All right, so that's all of our function notation. Are there any questions about that stuff or anything else you want to, anything you need more examples? All I have left is increasing and decreasing, and I think I can finish it. I'd really like to, if that's okay. I know I've talked for the whole hour. I promise I'll make it up to you. But I just would like to wrap this up. I think we can. So the last piece is increasing, decreasing, and constant. Increasing just means as you go from left to right, your graph is right. So it's just something like that. Decreasing means your graph is falling as you go from left to right. Constant would be no change. So like, that's kind of decreasing. A horizontal line, if you can draw a nice horizontal line. The key for all of these is the from left to right thing. When I give something like this, people always want to tell me that's increasing because the line's going up. But as you go from left to right, it is falling. So don't let those arrows confuse you. You're going just from left to right. We will answer these giving intervals. And when we use intervals, we always list the x values. The reason is in a function, x never repeats. So if I say x equals 4, I know exactly where to go on my graph. If I say y equals 4, that could be multiple places on one graph. So we always list the intervals with our x's. Okay, so we are just going to look at this graph and tell where it's increasing, decreasing, and constant. And I think it's easiest really just to start on the graph and go from left to right. So this graph starts at negative 8. What is the first part of my graph doing? Decreasing. So starting at negative 8 and ending where? Negative 5.5. So decreasing from negative 8, comma, to negative 5.5. What does it start doing at negative 5.5? Increasing. Does it stop when you get to that end of the semicircle? Still going up, so it's increasing from negative 5.5 until you get to an x value of 2. What's happening at 2? Constant. From an x value of 2 until you get to 6. And then what's it doing at 6? Decreasing. Let's make this into a nice point down there. So it's decreasing again. If there's more than one piece, you put the u in between. And that's from 6 until I get to approximately an x value of 9. what is the first section of my graph doing? Decreasing. Where is it coming from? What x value did I list? Negative infinity. And it stops decreasing where? Negative 3. Remember, we always list the x. Would I put a parenthesis or a bracket in negative 3? Parenthesis because of the open circle. Okay, my graph picks up again when x is 1, and at that point it is increasing from 1 until 4. And then starting at 4, my graph is constant and it keeps going, so from 4 to infinity. I want to look at an example in the book. So grab a book, 1 per table is fine, you guys can share, but I want to look at the graph on page 212, example 10. Okay, so it tells us, this shows the relationship between the number of gallons of water in a small swimming pool and the time t in hours. By looking at the graph, we can answer questions about the water level at various times. So part A, what is the maximum number of gallons of water in this pool? 3,000. You guys see that? The highest point is right here. That's when your y value is 3,000. Okay, when is that water level first reached? After 25 hours. B, how long is our water level increasing? From 0 to 25, so it would be increasing for 25 hours. How long does our water level decrease? It decreased between 50 and 75. So 25 hours. How long was it constant? 50. It's constant between 25 and 50 and 75 and 100. So a total of 50 hours. It was constant. How many gallons of water are in the pool after 90 hours? Yeah. 90 would be right there, and that's when you had 2,000 gallons of water in the pool. Okay, describe a series of events that could account for the water level changes shown in the graph. So tell me a scenario that would make sense with this graph. Okay, filling up the pool. Would it make sense to say it rained and you got water in your pool?
No.
Why?
It's 3,000 gallons of water.
Okay, would it rain 3,000 gallons in 25-hour period? Probably not. Now, if it were a very small increase, then maybe that would be reasonable, but probably not 3,000 gallons in a day. So we filled up our pool, and then what's happening? Nobody's swimming in it. We're letting the water warm up. What could happen right here? Evaporation. Would that account for 1,000 gallons? Depending in a 25-hour period? Maybe over a longer time frame, but you're probably not going to lose a third of your water in a day. Okay. Okay, maybe you had, kids in the pool. If it's my kids, they're going to take buckets of water and start throwing it over the side because that's fun. So maybe it's kids in the pool. Maybe you got a leak in your pool or something like that. So that would account for a decrease. And then what's happening? Yeah, I made the kids go back inside. Okay, the water's sitting there again. Okay, on the next slide I put a couple other questions for the same graph. Over what period is the water level changing the most rapidly? Where is the most rapid increase? Here
5 hours.
to 25, yeah, for 25 hours. After how many hours does the water level start to decrease? 50. And how many gallons of water are in the pool after 75 hours? 2,000. So I just want to make sure you guys can read graphs and answer questions about those. Do you have any questions? Okay. So, we have a whole 4 minutes. Plenty of time to start your homework, right? So I told you I'd make it up to you for teaching for the full hour. Tomorrow is a work day. Okay, so here's the assignment. I will give you class time tomorrow to work on this. It is not due until Wednesday.
Thank you.
You're welcome.